Hi everyone, sorry for the delay in the creation of new recordings and video. So normally in this session, we will talk a little bit about probability and have the review from grade 7, okay, to complete our new chapters of grade 8. So normally, what about probability and when we use probability? We use probability every day in our lives, okay? Like when we say it is likely to rain today, it's likely, so it is, we have a big chance for raining, okay? So normally when we talk about statements that where the chance belongs, where the chance intervene, okay, intervene. So normally we talk about the chance of something occurring. So normally all we talk about probability. Okay, so it is all about the likelihood of something happening. And when we use some vocab of probability like certain, very probable, highly likely, not highly, no chance, and small chance, and even chance. So what we should know and begin our lecture and our session with some vocab that we almost and always use with probability. First of all, we should know what we mean by the sample space in a random experiment. So we have a random where the chance, where we have a chance experiment, random experiment, we mean chance experiment. Okay, we should know the sample space. We should know that the sample space is the set of all eventuality, of all outcomes. So normally the possible result of a chance experiment are called outcomes, and the sample space S is the list of all these possible outcomes and eventualities. So normally, for example, if we toss a coin, we will obtain normally once we will obtain head or tail. So normally head or tail give us the set of all possible outcomes that we call the sample space. Okay, and the theoretical probability, if we want to compute the probability of occurring some outcome or some event. So normally we should know that the event, first of all, is either one outcome, okay, or a collection of outcomes. So it is a singleton from the sample space, one outcome, or is a subset of the set of list of the sample space. Okay, so normally when we want to compute a probability, we should use this quotient, this rule. It is the quotient of the number of favorable outcomes over the number of possible outcomes. Okay, so as I said before, an event can be defined as subspace of the sample space, and the number of possible outcomes is the total number of elements constituting the sample space. So normally the cardinal, the number of elements of our sample space, and the favorable outcomes are the elements that verify our statement or our event. Okay, first of all, to calculate the probability of an event, we first of all find the sample space. Secondly, we count the number of elements of the sample space, and we count the favorable outcomes, and we apply this rule, as we said before, that the quotient of the number of favorable outcomes over the number of possible outcomes. We should note also that the probability is a value between 0 and 1. Okay, so it is impossible to compute the probability and to obtain a value greater or equal greater than 1 or smaller than 0. Okay, the percentage probability is equal to the probability that we calculated before using this rule, and we multiply it by 100. It is easy to know that the probability of impossible event is always 0, or the probability of certain event equal to 1. Okay. What we mean by or what we seek, or what we have to know about the informal concept of chance. Okay, so normally we have the impossible, or no hope, or no chance has a probability equal to 0, and the certain equal to 1 when we have a sure thing to occur. Okay, and the highly probability, the likely to like when we have a big chance, a good chance, high hopes to occur some event. So normally its equivalent probability has to be greater than 1/2, and the event with a probability less than 1/2, it is categorized as unlikely, rarely, small chance, and little chance to occur, and slim chance to occur. So first, we starting with the exercises and the application. For example, if we have a hat contains 1 pink, 1 red, 1 blue, and 1 green ticket. So 1 ticket is chosen at random. What the list of the sample space? Normally, if we pick one ticket from this hat, so the all possible outcomes can be pink, red, blue, green. So normally the sample space is the set of all these outcomes. What is the probability of selecting the red ticket? The red ticket, we have a one red ticket from 4. So normally the favorable outcomes at red is 1. From the possible outcome, the number of possible outcomes equal to 4, and so on. All these exercises you can assess your information about probability are very easy. For example, moving on to the 4th exercise, a box of ice creams contains 8 chocolate, 5 strawberry, and 3 vanilla. 1 ice cream is chosen at random. How many ice creams are in the box? Normally we have these outcomes. These outcomes are, we add these numbers to obtain 16 ice creams in the box. How many ice cream are strawberry? 5. And what is the probability of selecting strawberry ice cream? We have the probability of selecting ice cream equivalent or equal to 5/16. We have because we have a 5 strawberry ice cream from 16 ice creams from total equal to 16. And also everything is easy. 1 card is selected. We are playing with cards. We're playing cards, okay? And we want to select 1 card at random from a normal deck of 52 cards. We know that we have a 52 cards, 13 from each color, each type. We have a heart, diamonds, club, and spades. Okay. So normally, what is the probability that is a club? Normally, it's a club. We have a 13 from 52. A black card. A black card. We have these two. These two. The club and the spade are black cards. So normally we have a 26. We have a 26 from 52. 26 from 52 equal to 1/2. And the black ace, we have only 2 black ace. From in each type, we have 1 ace. So we have a 1 ace here and 1 ace here. We have 2 black aces. So normally 2 from 52, 1/26 as a reductive fraction. So very easy also to convert from percent probability to decimal probability, because when we say 65%, so we mean 65/100, 30% we mean 30/100, and 5% we mean 5/100, okay, and so on. When did they ask about does not catch a bus, for example? Not catch a bus normally could be they could drive, go by driven, or walking. So normally we have like 100 minus 30, or we can say it is 65 plus 5. 70%, 70 from per 100, and so on. Okay, and you can complete all these one by yourself. Also, it is very easy to know that when we have a box of chocolates has milk and dark chocolates, one chocolate is selected at random. The probability of selecting a milk chocolate is 3/10. What's the probability of selecting a dark chocolate? We have a chocolate, dark chocolate, and milk chocolate. So normally the probability of selecting a dark chocolate is the remaining of from having milk chocolate. So normally it is 1 minus. So for us, the dark chocolate as an event is the complementary of milk chocolate. So normally we should know that the probability of a complementary event, okay, complementary, I will symbolize it like that, equal to 1 minus the probability of having the event. So normally or having dark chocolate or having milk chocolate. So normally having dark chocolate equal to 1 minus the probability of having milk chocolate. These are the information, the important one that we should know and revise about probability. Thank you for listening. Bye-bye.